Okay, this video will be a review from section 6.2, and 6.2 is all the simplifying rules. So this first video will focus on no variables involved. So again, I would pause the video and work through these, and then see if we get the, you can fast forward, see if you get the answer, and if not, listen to the explanation. All right, so the first one is 5 to the 2/3 times 5 to the 1/4. So again, if you have the same base, you keep that base the same. And when you're multiplying like bases, you add the exponent. So it's going to be 2/3 plus 1/4. And of course, with fractions, you need common denominators. So between 3 and 4, that would be 12. So that would change to 8/12 and 3/12. And 8 plus 3 is 11. And then last but not least, you should always check, can you take the 12th root of 5? Obviously, and this would be no calculator question, so clearly you cannot. And that would be your final answer. The second one, you have like bases. You could add the exponents, but this one has a power on a power, so you have to take care of that first as order of operations. So when you have a power on a power, remember you distribute, so 3 times a half would be 3/2. And then you need, again, you have like bases, so when you have like bases, that stays the same, and multiplying means you add those exponents, and then common denominator would be 6, so 3/2 as a 6 would be 9/2, and 1/6, oops, sorry, not 9/2, 9/6, and 1 plus 9/6 would be 10/6, and you should reduce that, of course. 10/6 would be 5/3. Now, do you know the third root of 8? And yes, you do. And you should be, if you want to, you could write this as the third root of 8 to the 5th. Not that you have to, but that's what it's saying. Okay, so you know the third root of 8 is 2, and 2 to the 5th is 32. So if this were a test question, not only are you simplifying, but then you have to recognize when you get to your final answer that you can actually reduce that. So be real careful and check every numeric answer. Okay, the next ones, pause the video, see how you do. Alright, so here you do not have like bases, you do not have like exponents, so you can't do anything, but I can always distribute a power on a power. So I guess I would start there. So 27 to the 2/3 times 6 to the 2/4, but that's 1/2. And then can you reduce things? So this is really the third root of 27 squared. In fact, if you want to write that, you can. You don't have to do that. And I know the third root of 27 is 3, and that 3 squared is 9. I don't know the square root of 6, and then be really careful. I can't take 9 times 6 because the 6 is raised to an exponent that is not the same as the 9. So that is your final answer. Over here, not like bases and not like exponents, so I'm going to distribute that exponent through. You could, if you thought about doing this, this is 2 squared, so you could make that 2 squared cubed, which would be 2 to the 6th, but if you did that, I just want to let you know that's fine. So negative 1/3 times 3 is -1, and 15 times -1/3 is -5. So I will, since I have both negative exponents, I will flip those all, or both, over 1. So it's going to be 4 to the 1st times 2 to the 5th. And 4 to the 1st is 4, 2 to the 5th is 32, and you could do this without a calculator for sure. So 1 over 128. Alright, this next group, see how you do with them. So here you have like bases, so you don't take 16 divided by 16. If you have like bases, the like base stays the same. So what do you do with exponents when you're dividing? You subtract them. So I'm going to take 7/12 minus 1/3, and common denominator would be 12, so 7/12 minus 4/12, and 7 minus 4 is 3/12, and that would be reduced to 1/4. And do you know the fourth root of 16? Yes, you do, and that is 2. Okay, the next one, you do not have like bases, but you do have like exponents. So you could distribute the third power through first, or because you have the same exponents, you can actually divide the bases. So remember, when you have like bases, you deal with the exponents. When you have like exponents, you deal with the bases. So 18 divided by 9 is really 2 to the 1/4, and that's still cubed. Now again, if you cubed these first, that's fine. This would just be a 3/4. Well, now see, I'm going to get that. So I distribute power on a power, right? Multiply, so 3 times a fourth is 3/4. And that's the same as the fourth root of 2, but without a calculator, I don't know what that is. Or maybe, 2 cubed is 8, so you could write the fourth root of 8, but you certainly don't need to do that. So that's as far as we can take it. Okay, see how you do with all of these radicals. So the first one, you have the same root, third root, third root. So I'm going to multiply those bases together because it's the same root, and 25 times 5 is 125, and I know the cubed root of 125 is 5. Third root of 40, well, there are no perfect thirds in 30, so if I think about all my perfect thirds, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, and I'll stop. And then I look, do any of these perfect thirds, are they multiples of 40? And obviously 40 is 8 times 5, so I'm going to rewrite this as the third root of 8 times 5. You can also, and well, let me finish my thought. The third root of 8 is 2, so I know that that's really just a 2, third root of 5, which is your answer. If you like to break things down, you could write that as the third root of, when you do 8 times 5, 8 is 2 times 2 times 2 times 5, and I know some of you do that, and then you see that there are a group of 3 2's, so you'd bring that out, and then the third root of 5 you can't, and that's totally fine, so whatever you prefer. The last one, you have both the fifth roots, so you can multiply 16 times 6, you can multiply that out, and you get 96. And again, now I'm looking for perfect fifths, so 2 to the fifth is 32, and I'm going to stop there because I know 32 goes into 96 3 times, so I'm going to rewrite that as 32 times 3, and I know the fifth root of 32 is 2, so it's 2 fifth roots of 3. If you prefer to break things down, you could break that down to the fifth root of 16 is 2 times 2 times 2 times 2, and 6 is 2 times 3, and then you see that there are 5 2's, so those 5 2's cancel out and bring it out, and then you've got the fifth root of 3. All right, last slide. You have the same root. So if you have the same root or exponent, remember you can deal with the bases, and I would definitely do that first. Like, I would not rationalize this because then you're going to create a bigger problem. So 96 divided by, that's a fourth root, 96 divided by 2 would be 48. And then you're looking for perfect fourths. So 2 to the fourth is 16. Well, I'm going to stop there because, again, I know 16 goes into 48. So I'm going to rewrite that as 16 times 3, and the fourth root of 16 is 2, so it's 2 fourth roots of 3. If you prefer to break this down, right, so 48 is 16 times 3. Well, 16 is 2 times 2 times 2 times 2 times 3. And then you see the 4 2's there, which you bring out, and you, again, get the same answer. Okay, the last one then, you're adding. Remember when you add, you have to have the same radical or exponent and the same base. So these two I could add because they're both fourth roots as long as the bases are the same, which they are not. This one is a square root, so it kind of stands alone. So I'm going to note that I can't add that one to the fourth roots. But I'm going to take out perfect fourths, all the perfect fourths I can, and perfect squares in this case. And I know that, well, I have one perfect fourth right here. 2 to the fourth is 16, and maybe 16 goes into 162 or 512. Okay, so other perfect fourths, 2 to the fourth is 16, 3 to the fourth, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 4 to the fourth, 4 times 4 is 16, 16 times 4 is 64, 64 times 4 is 256, and I think I'll stop because if this were on the test, I wouldn't probably expect you to think about too many fourths beyond this. But I'm going to start with 162, and I do know that 16 won't go into 162. 81, however, goes in there twice, so I'm going to rewrite that as 81 times 2. And then I know the fourth root of 81 is 3 because I just figured that out. So that simplifies. Now the square root of 200, now I'm thinking perfect squares. Well, that's obviously 100 times 2. And so that's going to be 10 root 2. And lastly, 512, let's see, 16 goes in there, 81 does not, but 256 is even better because 256 times 2 is 512. So I'm going to, let me start over here. I'm going to rewrite that as 256 times 2. And 204th root of 256 is 4. So I have 4 fourth roots of 2. Now, if you're thinking to yourself, I don't know that I would have saw that. Here's my little bit of advice. When you have common roots, after you simplify the easier one, and you note that it's a fourth root of 2, then you know that to add, this is going to have to be the fourth root of 2. So divide that by 2, because you know you want to end up with a 2, which would get you the 256. And then maybe you'll have a light bulb moment and realize that's a perfect fourth. So now, since I have fourth root of 2, fourth root of 2, I can add 3 of those plus 4 of those would be 7 of those fourth root of 2's. And then the 10 square root of 2 is not a like radical, so that's as far as I can take it.